About logarithmic functions. Now, first, how do we define the logarithmic functions? So, logarithmic is defined in terms of an exponential. If b to power x equal a, then log base b of a is x. So, this is how we read it. So, if we have b to power x equal a, then log base b of a is x. So this is the definition of logarithmic, and it's related to exponential functions, and we're going to see that when we study graphing. So keep that in mind. If we have b to power y equal x, that's the same as log base b of x equal y. So we have the logarithmic form and we have the exponential form. If we want to convert 16 equal to 4 squared into logarithmic form, so we have the base is 4, so that's going to be log base b of 4 of 16 equal to 2. Now, if we want to convert to exponential form, log base 2 1 over 8 equal to -3. So that's going to be 2 to power 3 equal 1 over 8. So notice the base is 2 and the exponent and 1 over 8. Now we need to write each equation in exponential form. So if we have 2 equal log base 5 of x, so that's 5 to power 2 equal x. If we have 3 equal log base b of 27, and we need to write it in exponential form, so that's going to be equal to b cubed equal to 27. Then the last one is going to be e to power y equal to 33. Now we have more example. Keep in mind, we need to write now in this slide each equation in equivalent logarithmic form, and we're using the formula b to power y equal x. So this is equivalent to log base b of x equal y. So the first example we're gonna see, so if we have 5 squared equal x, so that's the same as log base 5 of x equal 2. If we have b cubed equal 64, that's the same as log base b of 64 equal to 3. So if we have 3 to power y equal 7, that's the same as log base 3 of 7 equal y. Now these are the properties of logarithm, and we're gonna use these properties to solve more examples. So we need to evaluate each expression without using the calculator. Definitely we're gonna use the properties we saw in the previous slide. So if we have log base 4 of 16, we're gonna write 16 as 4 squared, and we notice that we have the bases match each other, so the answer is the exponent. So we're gonna write 1 over 5 as 5 to power -1, and we notice the bases matches, so the answer is -1. Again, another example where the bases matches each other in logarithm, so the answer is half. So we're gonna write 8 as square root of 64, and we know the square root of 64 is 64 to power half, so the answer is half. Log base 4 of 1 is 0, but also keep in mind that 1 is the same as 4 to power 0, so that's why is 0. Another example using the properties, the answer is going to be 19. And finally, log base 3 of 1 over square root of 3, that's going to be negative half. More properties. Now we have the natural logarithm, which is base e, and don't forget, anytime we have log without any base, that's base 10. So for the first one, we're going to write 100 as 10 squared, so the answer is 2. So we use property number 3 from the general properties. Now for the second one, we're using the same property, and that's 7. Now here we're using an old property, and the answer is 33. Ln 1 is 0. And ln e to power 6, that's 6. And ln 1 over e to power 6, that's negative 6. So we're using property number 3 in natural log. So application to the fourth property in natural log, and the last one is square root of x, and that's an old property. Now the graphs of exponential and logarithmic functions are inverse to each other. So if I want to graph y equal to 2 to power x, so notice we took points. So that's the graph of 2 to power x. Notice the graph of log base 2 of x. We have the same coordinates but converse. So that's the graph of log base 2 of x. And these two graphs are symmetrical with respect to y equal x in the origin. So the graphs of exponential and logarithmic functions, they are inverse to each other, and I can graph the graph of logarithmic function from the exponential one. Transformation rules, and they are the same for every function. So we're going to see examples of transformations. So we're going to take first the graph of log base 3 of x. Don't forget the vertical asymptotes. Now, if we move it 2 steps up, that's log base 3 of x plus 2. This one, it got flipped about the x-axis. And if we move it to the left 2 units, that's log base 3 of x plus 2. And don't forget also the vertical asymptotes will move to the left 2 units. Now domain, anytime we're trying to find the domain of the logarithmic function, the quantity inside the log should be positive. So the domain of this function is negative 3 to positive infinity. Here we need to find the domain, and notice we have square, so x minus 3 could be positive. We need it to be positive. So we need x minus 3 squared to be positive, so x minus 3 could be negative or positive. Therefore, the domain is negative 3 to infinity, union 3 to infinity.